Going to talk about this question in two different ways. First of all, my approach was to go straight for some algebra. So I said the total distance was d and the total time was t. So for the first 10%, the average speed was the distance traveled. So 10% of the total distance is 0.1 d divided by the time taken for that period, 0.2 t. And that is actually going to be, if I times through by 10, d over 2t, or half d over t. And then I can look at the remaining 90%. So I got to show enough work in here. So the distance traveled is then going to be 0.9 d, and the time is going to be 0.8 t. So the average speed is going to be 0.9 d over 0.8 t, or 9 over 8 times d over t. So we're asked for the ratio, and it's the ratio of the first 10% to the remaining 90%. So it's going to be a half d over t to 9 over 8 d over t. Okay, I can just cancel these out now. I can times through by 8, so I'm going to get 4 to 9. A second approach to this problem, when I saw somebody do this, I was like, yeah, that is a quicker approach to get the answer. However, I'm now questioning whether in the grand scheme of the JMO, whether sufficient working is basically given, enough arguments. So what the person did is they assumed that d was equal to 100 miles and t was 100 hours, just to make life simple. Now we can see in my original problem that d and t both cancel out, so it is independent of d and t, but that's my problem with this approach. Can we actually assume without loss of generality? Because sometimes in maths it's absolutely fine. And for example, when you're finding fractions of areas and stuff, like you can just assume certain dimensions and it's not going to matter. But do we really know it's definitely sure here? So I'm kind of thinking maybe this is not the best approach for the JMO, but it is a quick method that I still want to talk about. So assume D is 100 miles. So for the first 10%, the average speed. I'm not writing this one in full, by the way. I'd probably write a bit more on the real thing. But remember, it was going to be 10 miles because it's 10% of the whole amount over 20% of the whole journey. So it's going to be actually 100 hours is quite a lot. So I'm going to change it to 10 hours, but it doesn't matter really. So this is going to be what is it? 10%. 20% is going to be 2. Sorry. So it's going to be 5. And then for the second 90%, B is going to be this 90 divided by 8, which I could cancel down to 45 over 4. So then the ratio is going to be 5 to 45 over 4. I think they worked this out as a fraction as 11.25, but actually it's going to be easier to leave it like this. We can times through by 4, 20 to 45, divide through by 5, 4 to 9 again. So the nice thing about this is there's no algebra. The thing I'm just going to emphasize again, not sure you should do this in a JMO just because, like, can you really get away with this? I think it's best to kind of be a bit more careful and use this approach here.